Hello everyone, and thank you for joining this tutorial on Kubernetes in Docker, commonly referred to as Kind. This is the first part of our series where we will cover the following topics: an overview of Kubernetes, different methods for creating local Kubernetes clusters for testing and learning purposes, introduction to Kind, setup options and prerequisites, hands-on demonstration for installing local clusters and deploying sample application. Let's begin without any delay. Kubernetes is the leading container orchestration software, responsible for managing the lifecycle of applications packaged in containers. It automates essential tasks such as deployment, scaling, and health monitoring, ensuring that containerized applications operate efficiently and reliably, especially at scale. Kubernetes boasts a rich feature set that includes self-healing capabilities, automated scaling, load balancing, seamless rollouts and rollbacks, service discovery, and many other advanced functionalities. There are multiple options for deploying Kubernetes in your own data center, such as using native Kubernetes or enterprise offerings like OpenShift and MKE. Alternatively, you can opt for KaaS, Container as a Service solutions like EKS, AKS, and GKE. They are provided by cloud giants such as Amazon, Microsoft, and Google. While setting up a large Kubernetes cluster is ideal for production environments, it's impractical for initial learning or testing purposes. Instead, there are lightweight options like Minikube, Docker Desktop, Rancher Desktop, and Kind available. These tools enable quick creation of local Kubernetes clusters using minimal compute resources, making them perfect for getting started or testing applications before deployment. In this tutorial, our primary focus will be on understanding Kind, which stands for Kubernetes in Docker. Kind is a tool designed to run local Kubernetes clusters using Docker container nodes. One of the key advantages of using Kind is its flexibility to set up both single node or multi-node clusters where each node operates as a Docker container. Kind can be installed on various operating systems including Linux, Mac OS, and Windows. The only prerequisites are having a container runtime interface such as Docker, Podman, or nerdctl, the kubectl CLI utility, and Go packages. To install Kind, simply visit kind.sigs.k8s.io and follow the installation instructions tailored for your operating system. Now let's proceed to a live demonstration. In this demonstration, we will start by setting up Kind, which is Kubernetes in Docker. We will then learn how to install a default cluster, proceed to create a named cluster as well, and deploy a sample web application on both clusters. Following that, we will create a new cluster using a specific Kubernetes version of our choice. We will also cover the process of deleting Kind clusters and conclude by deploying an application and exploring how to access it. You have the flexibility to use any operating system, including your local laptops. For simplicity, I will demonstrate by creating a new Ubuntu machine on AWS Cloud. Let's name it Kind Demo. Choose Ubuntu 24.04 and consider starting with a smaller instance type like t2.small, but in this case I am using t2.large. I will use my existing key pair and a default security group that has rules to allow all access for this demo. Let's adjust the disk size to 30 GB. We can now proceed to launch our instance. Our instance is now running. Let's log into our instance and change its hostname to Kind Demo. Now switch to Kind official documentation at kind.sigs.k8s.io to check the prerequisites. As you can see here, Go package and CRI, which can be Docker, Podman, or nerdctl, are the two main prerequisites. Now switch back to our terminal and check if Go package is installed or not. As you can see, the Go is not installed. So let's run apt install golang-go command. So you can see it's failed because we have to update the repositories. So let's run apt-get update first. This will actually going to update the repositories for Ubuntu packages. Once done, now let's run apt install golang-go again. And this time you can see it is installing Golang package for us. It's done. Now let's run go ---- version. It's failed, so just do go version. And you can see 1.22 Golang version is installed on our Ubuntu machine. Next, we need to install Docker. So run apt install docker.io, which will going to install Docker for us. So Docker is installed. Now let's run docker ---- version to confirm the Docker version 24.07. Let's run systemctl status docker to check the status of Docker engine. So it is active and it is enabled. Now we have installed Golang as well as we have installed Docker. But in order to interact with the cluster, we need to install kubectl, kubectl utility as well. So let's switch to kubernetes.io documentation, go to documentation, click on learning environment, and you will see install tools here. So click on that and you will see install kubectl on Linux. Just we are using x86 64 based architecture. So we will just going to copy this command and going to paste it on our terminal. So we have kubectl here. So let's move kubectl to user local bin. So it's there. Let's try to run kubectl ---- version to check the version of our kubectl utility. See here, we are getting a permission denied error, which means we have to give the executable permissions to kubectl utility. So we are going to run chmod +x to user local bin kubectl. So once done, let's run kubectl ---- version command again. So just remove ---- just do kubectl version, and you will be able to see 1.30.3 version of kubectl utility has been installed on our Ubuntu machine. So we have Go, which is 1.22.2. We have Docker, which is 24.0.7, and we have kubectl utility, which is 1.30.3. So all of the prerequisites are done. If you run kind now, you will see there is nothing. So as all prerequisites are met, we are going to install kind now. So let's switch back to the documentation. Just click on quick start and you will be able to see that you can install kind using release binaries from source or as a package manager as well. Or see here the release binaries, so you can install it on Linux, on Mac OS or on Windows. Likewise, you can install it from source. And you can also have option to install it with a package manager as well. We are going to use the first method, which is release binaries. So on Linux, see here we have x86 64 architecture. So we are going to copy this first command and we are going to execute it on our machine. So if you do ls, you will be able to see kind here. So let's change the permissions to executable for this first. So chmod +x kind, and let's move kind utility to user local bin. Done. So now you will see ls usr local bin /kind. You will be able to see it's available there. Now let's do kind version, and you will be able to see 0.23.0 version of kind is installed. So you can see how simple it is to install kind. So now what we are going to do is we are going to get started with a simple cluster first. So we are going to create a simple default cluster. It's very simple. Just do kind -- help and you will be able to see all the available commands. And you will see create here. So what we are going to do is we are going to use kind create. So it's kind create cluster and just enter. It's as simple as that. And you will see it is actually started downloading the image, which is of version 1.30.0, which will going to be your Kubernetes version as well. So let's wait for a couple of seconds and you will see the kind will going to create an entire one node cluster for us. It's a single node cluster because we are using a default cluster here. That's it, all done. If you see our cluster is all ready. So let's run a command called kind get clusters and you will see the cluster. One cluster is available with a name called kind. You can do kind get nodes, which will going to tell you a node name as well, which is showing kind control plane here. So you do kubectl get nodes and you are going to see a single node here. See the node name and the kubectl get nodes is showing same. So it's ready and it is showing 1.30.0 Kubernetes version. Now you might be thinking, what is this node? This is nothing. This is just a normal Docker container. So if you do Docker container ls, you will be able to see one container. And if you closely check the name of a container, you will see it's kind control plane. So this is nothing. This container is acting like a node for us. So whatever you do in kind, it will going to create a Docker container which will act like a node, like a VM. So if you run kubeconfig get clusters, you are going to see the details. If you see here kind, it's a cluster. Likewise, if you run kubectl config get contexts, you are going to see the context as well. At present point in time, there is only one cluster and one context. So let's see where the kubeconfig file have been created. So we are running everything as a root. So go inside of root home directory .kube/config and you are going to see everything there. You can open this file and you will be able to see the entire details of your kubeconfig file there. So let's do it. See here everything. Now see this name is kind and see here the 127.0.0.1 and port is 40491. Now this 40491 is the exposed port in your Docker container. So if you do Docker container ls now, you will be able to see the same port details, which will be forwarding the things to your 6443, which is your kube API port. So kind get clusters, we are having a single cluster now. Now what we are going to do is we are going to create another cluster with a name. So if you do kind create cluster -- help, you will be able to see a string called -- name. So we are going to leverage that. Otherwise, by default, it will going to create a name as kind. So kind create cluster -- name. So let's give it a name called demo cluster. That's it. Enter and it will actually going to create a new cluster with a name called demo cluster. As you can see, it is actually going to create 1.30.0 Kubernetes cluster for us. That's it. So our cluster is created. So let's run kind get clusters. And this time you will be able to see two clusters here. One with a name called demo cluster, which we have just created. And one is the older one, which is kind. If you wanted to see all nodes, you have to do kind get nodes -A. So it will show you two nodes. Now when you do Docker container ls, these two nodes are two different containers. See here, demo cluster control plane and you have kind controller plane or kind control plane. So these are two nodes which are running as containers. Verify everything using kubectl command as well. So let's do kubectl config get clusters. You will be able to see two clusters here now. And you can do kubectl config get contexts as well. If you closely see, as soon as we create a new cluster, the context will going to get changed to a new cluster. So whatever commands you run as kubectl will going to run in demo cluster. Let's say we wanted to check the information about our cluster. So just run kubectl cluster info. And let's say you wanted to check it for kind cluster. So you have to just do -- context kind. Likewise, you can run kubectl cluster info -- context and give another cluster name, and it will going to give you the details about the other cluster. See the port numbers 40491 for the kind cluster and 36703 for our demo cluster. So now we have two clusters with us of version 1.30.0. Let's try to see how to deploy applications on them. So as a developer, I'm working on two different applications and I want to test them in separate clusters. So how can I do that? So let's run kubectl config get context command first and check the details about the context. So we have two clusters here. So let's run kubectl create deployment name. So in this case, I am giving demo cluster dep and then -- image, and let's say we are using httpd : latest image in this case. So by default, if I run this command, it will going to run in a demo cluster because the current context is set for demo cluster. See here, our deployment got created. So kubectl get deploy, we have deployment in ready state, replica set is all set, and kubectl get pods, you can see our pod is in a running state. Now let's try to scale this. So kubectl scale deployment demo cluster dep -- replicas. Let's say we are replicating it to 3. So let's say equal to 3, enter. As soon as you do it, just do kubectl get pods and you will be able to see all of our 3 pods are running. And they all are running on our demo cluster. Now let's say you wanted to run things in a kind cluster as well, which is not having a current context set. How can we do it? So let's run kubectl create deployment name, let's say kind cluster, let's say client cluster dep, and then we have -- image, let's say in nginx : latest. This time you have to give -- context equal to kind. Because we wanted to deploy this deployment in a different cluster, which is not having a current context set. So you just need to add -- context, enter, and you see things got created. So kubectl get pods, you have 3 pods, which is in the current context, not in the kind. So if you wanted to check the things, you have to run kubectl get deployment -- context kind. And you will see 1 and you have kind cluster dep as a deployment name, which we have just created. Let's check the same thing for replica set and for pods as well. So kubectl get pods -- context kind. See here, our pod is running and it's having a single replica. Now let's say you want to scale your deployment. So kubectl scale deployment name, which is kind cluster dep -- replicas equal to 3. Now if you see here, we got an error because I haven't set the context there, and by default we don't have kind cluster dep in our current context. So kubectl scale deployment name -- replicas equal to 3 -- context kind. And as soon as you enter, you will see it is scaled. So kubectl get pods -- context kind is showing 3 pods to us now. So this is how you can play around with different applications on different clusters with simplicity. So let's check the clusters now. So kind get clusters. So we have 2 clusters now. Kind get nodes --A. So we have 2 nodes now. If you do docker container ls, you will be able to see 2 containers which are having a same name as that of our nodes. But if you closely see, these both clusters are running on 1.30.0 version of Kubernetes. Now if you closely see this image, kindest / node : v1.30.0. Even if you run kubectl get nodes on both of the clusters, you will be able to validate that both of the clusters are running on 1.30.0 version of Kubernetes. So kubectl get nodes and then -- context kind, enter, and see. So both clusters are having 1.30.0 version. Now consider an example or consider a case where you want to test your applications on a different version of Kubernetes. How to do that? That's very easy. Just switch back to hub.docker.com and search for kindest namespace. As soon as you run it, you will be able to see kindest/node, which is actually a sponsored OSS image. Now click on that and just go to tags. When you go to tags, you will be able to see different versions of images here. And these different versions are corresponding to different Kubernetes versions. See this 1.28.9, 1.27.13. So they all are corresponding, or they all are referring to different Kubernetes versions. Now let's try to create a Kubernetes cluster with a different version. So kind create cluster -- help. So we are having a name string as well as we are having an image string, which we are going to use now. So kind create cluster -- name. Let's say we are giving it a name called Thinknyx demo, followed by -- image. So this is a place where we are going to put the image name. So we will put kindest/node, which is an image name, and then we are going to put a tag. So tag, we are going, let's say we are using 1.28.9. So let's put 1.28.9. Enter. So as soon as you enter, if you observe, it started creating 1.28.9 cluster. Let's wait. If you see here, it failed, which means we are having some issue with our image name. If you closely see this image, kindest node 1.28.9. So if you see, we have missed V. So we have to give V 1.28.9. So it was an error. It was a typo. So kind create cluster. So we are going to use V 1.28.9 this time. And see here, the process started again and it started creating a cluster for us now. So let's wait for a couple of seconds and see how it worked. Perfect. See here, it completed now. So our kind Thinknyx demo cluster is ready. So let's run kind get clusters and see there are 3 clusters now. So Thinknyx demo, kind and demo cluster. So kind get nodes -a and you will be able to see 3 nodes, each corresponding to a individual cluster. If you do run kubectl config get -contexts, you will be able to see 3 contexts now. And as soon as we create a new cluster, the new context will going to be the current context as well. So kubectl get node, see this 1.28.9, as we are running it in the current context, which is Thinknyx demo cluster for us. So the new cluster got created and it is having a version 1.28.9 because we have used 1.28.9 version of an image. So now let's see how to delete the clusters as well. So let's try to find out whatever we have installed so far and delete them. So kubectl get deployment context kind. So you will see one deployment there. So let's delete that deployment first. So kubectl delete deployment name -- context kind. It's got deleted. Let's verify the same for kind demo cluster as well. So we have a running deployment there. Let's delete that deployment as well. So kubectl delete deployment name, which will going to be demo cluster dep, and then context kind -demo cluster. Enter. Done. Now, in order to delete your kind cluster, what we need to do is we need to use kind delete command. So before that, let's check the cluster. So we have 3 clusters. So kind -- help. So we have delete option here. So kind delete -- help. And you will see cluster and clusters. Cluster to delete single cluster and clusters to delete multiple clusters. So kind delete clusters -- help. If you use -a, it will going to delete the entire thing. So whatever clusters we have provisioned, it will delete everything. But we want to delete only 2 clusters. So what we are going to do is we are going to use kind delete clusters and then followed by name of the clusters. So cluster name 1 and cluster name 2. So let's get the clusters names first. Kind get clusters, kind delete cluster, clusters, demo cluster and kind. So it will going to delete 2 clusters for us, demo cluster and kind. See here, deleted nodes and deleted cluster, which means containers will also be removed now. So if we run docker container ls, this time we will just be able to see a single container, which corresponds to a new cluster which we have built for version 1.28.9. So if you do kind get clusters, we are having a single cluster. Kind get nodes, we are having a single node. And hence that's the reason we are having a single container at present point in time in our machine. So if you do kubectl config get contexts, you will be able to see a single context now. So now we have a single cluster. Let's try to deploy a deployment and a service and try to access our application. So let's run kubectl create deployment demo app dep, and let's say we use -- image equal to httpd:/latest. So web image. Enter. Deployment created. So let's do kubectl get pods. Container is in creating state. Let's wait, run it again, and see here we have our pod in a running state now. Now what we are going to do is we are going to create a service, and we will associate that service to our deployment. So at present point in time, there are no services. There is only one default Kubernetes service. So kubectl expose --help. And let's run kubectl expose deployment or deployment name, which is demo app dep --port equal to 80 --target -port equal to 80. Let's give a name to a service demo app dep svc. And let's say we wanted to create a type of node port. So type node port. We cannot use small and small p. So if you see there, so we have node port there in the command. So just copy that, paste it, capital N, capital P, enter, exposed. Kubectl get pods, kubectl get svc. So you will be able to see our service got created, which is having a service IP associated with it, and everything else is done. Now, in order to access your application, what we need to do is we need to log in into our container. So docker container ls, let's log in into this container, docker container exec -it, name of our container or ID, whatever you want to use. I'm using a name here, and then bin bash /bin/bash. Enter. So we are inside our control plane now, inside our cluster now. Let's run curl. Just copy your service IP. Which is 10.96.86.34. So copy it and port number 80, enter. See here, we are able to access our application. So our web application is showing it works. So this is how you create clusters, you deploy applications, and you access your applications. So finally, you can go ahead and you can use the same process and you can delete your cluster as well. So it's completely up to you. If you want to delete your cluster, you can just use kubectl delete cluster --name and the name of the cluster, and it will going to delete the cluster for us. So that's it for this demo. In this demo, we have shown you how a single node cluster can be created using kind. We also understand if we wanted to create a different version of Kubernetes, we can also do that very easily using kind. In the next part of this series, what we are going to do is we are going to cover how to create multi-node cluster in Kubernetes using kind. So stay tuned.
Thinknyx. You trust, we deliver.